Welcome back students in a new series. In this video lecture, I'm going to discuss about machines, some of its important terms and two very basic kinds of machine as a lever and a pulley. So let's start. Do you know that in your day-to-day life, you come across different kinds of machines such as the scissor which you use to cut a piece of paper, or a screwdriver which you use to open or tighten up a screw. Then, have you often thought that what is a machine? How you can classify it? Let's understand about that. A machine can be anything which can help us to do some kind of work, which can make our work easier, faster, and effortless. It is a device which helps us to lift a heavy load or speed up the motion, or it may change the direction of the force which we use to apply to do the work in our desired condition. Thus, we can say it is a device by which we can either overcome a large resistive force at some point by applying a small force at a convenient point and in a desired direction, or by which we can obtain a gain in speed. There are various kinds of machine. Do you know that many of our body parts also behaves like a machine? We will come across in this chapter that how and where we use different forms of machines. Now, let's understand what are the various kinds of machines. We can classify a machine into different forms, but the very basic form in which we can classify it, that is a simple machine and a complex machine. A machine is a device that helps us to do the work with less effort in less time, is a simple machine, where we observe that they are made up of only few parts or no moving parts. Whereas a complex machine or a compound machine is consist of two or more simple machines. You can see a complex machine as small as a mechanical watch, or it can be as large as a construction crane. At your home, you have different kinds of simple machine as a hammer, scissor, broom, wheel, tongue, etc. When we classify this simple machine, then we come across about two different forms, that is the lever family and the inclined plane. In the lever family, we observe a simple lever, pulley, wheel and axle, whereas in the inclined plane, we come across about an inclined plane, a wedge, or a screw. In this chapter, we will mainly focus on simple lever and pulley with pulley system. Now, with the discussion, you may know what is a machine. In a simple way, you can now explain a machine as a device which helps us to do our work in a better form. And as I said, we will discuss about simple machine in detail. So now we will understand a simple machine and various terms related to that. A simple machine is a device that alters the magnitude or direction of the force applied. And the various terms which is related with a simple machine are load, effort, mechanical advantage, velocity ratio, work input, work output, and efficiency. So let's understand what these are. Let's understand the first term as an effort. What is an effort? Effort you can say as the force applied on the machine in desire to do some work, or the force which we are applying on the machine to do some work is said to be as the effort. Whereas the load is the force that the machine has to overcome with the help of the effort. Fulcrum is a fixed point about which the machine can turn. With this, we have to calculate some numericals related to the machine. That is, a mechanical advantage and a velocity ratio. The mechanical advantage is the ratio of the load to the effort, whereas the velocity ratio is the ratio of the displacement of effort with displacement of load. Both mechanical advantage and velocity ratio used to be compared with 1. Mechanical advantage or velocity ratio gets greater than 1, it means that the machine is a force multiplier. In simple words, you can say the machine enhances the force to do the work. Whereas, if the mechanical advantage or velocity ratio gets less than 1, then we observe that the machine gains in speed. You can say that the displacement of load is greater than to the displacement of effort. And if the mechanical advantage and the velocity ratio becomes equal, then that kind of machine is only used to change the direction of the effort applied. Hence, you can say that there is no gain or loss of the force or speed, just the force direction or the application of the direction force got changed. With this, you also have to understand about efficiency. What is efficiency? Efficiency is a simple calculation of work output with respect to work input. What is work output? Work output is the work done by the machine, whereas work input is the work which we do on the machine. Let's understand the relation between efficiency, mechanical advantage, and velocity ratio with each other. Here, you can have a simple calculation which will establish a relation between the mechanical advantage, velocity ratio, and the efficiency of a machine. Here you can pause the video and go through this simple calculation. Here, if we take for a machine some terms as capital L for the load, capital E for the effort, with respect to the time period T, the displacement of effort as dE and the displacement of load as dL. We can calculate the work input as effort with displacement of effort, whereas the work output can be calculated as load into displacement of load. Once again, I would tell you what is work input. Work input is the work which we do on the machine, whereas work output is the work which we obtain from the machine. Hence, the calculation of work input is effort with displacement of effort, whereas the work output is calculated with the product of load with displacement of load. Now, if you go for the calculation of efficiency, you know the formula, that is load output upon load input. Now, when you go for the values, you will obtain this over there. If you split the equation, you will get load upon effort with the product of displacement of load upon displacement of effort. Here, the load upon effort is the mechanical advantage, whereas the displacement of load upon displacement of effort can be said to be as the reciprocal of the velocity ratio. Hence, at the end, we come to the calculation as efficiency equals to mechanical advantage upon velocity ratio, or you can say the mechanical advantage is equals to the product of velocity ratio with efficiency. Students, on the basis of efficiency, we can also classify a machine. Let's understand that also. Here, you can see that on the basis of efficiency, you can classify a machine into two basic forms, as an ideal machine and an actual machine. An ideal machine is that in which there is no loss of energy, whereas in an actual machine, we used to observe that the output energy is always less than the input energy. Hence, when we go for the calculation of this efficiency, then we observe that the ideal machine gives an efficiency always as 100%. But for the calculation of an actual machine, it is always less than to the 100% because there is some loss of energy due to various reasons. Now, let's discuss about the first kind of simple machine that we have to see in this lecture. That is a lever. A lever is a rigid, straight, or bent bar which is capable of turning about a fixed axis. The axis about which the lever turns passes through a point of the lever which is called fulcrum. This fulcrum is a point which doesn't move. It remains fixed when the lever is in use. Let's understand the very simple principle on which a lever used to work. The lever used to work on the principle of moment of force, where the moment of load about the fulcrum is equals to the moment of effort about the fulcrum. Hence, when we calculate this principle, we come across a simple formula where the product of load with load arm equals to the product of effort with effort arm. Under deriving this formula, we come across a simple calculation where mechanical advantage is equals to the effort arm upon the load arm. Students, you must understand what is an effort arm and a load arm. Effort arm is the distance between the fulcrum to the effort, whereas the load arm is referred to the distance between the fulcrum to the load. We can classify a lever in three basic forms. They are the first class of lever, second class of lever, and the third class of lever. And this classification is just based on the position of effort, load, and fulcrum with each other. If the fulcrum is situated between the load and effort, then we classify it as the first class of lever. Say as a scissor or a plier can be considered as a first class of lever. Whereas if the load comes between the fulcrum and effort, then it is said to be as a second class of lever. In a second class of lever, you can see a nutcracker, a wheelbarrow, and a bottle opener. Whereas if the effort comes between the fulcrum and the load, then it is considered as the third class of lever. Here you can see a facing rod, a pair of tongs, a stapler, etc. Now let's discuss some more things for a lever. When we go for the calculation of mechanical advantage velocity ratio for the three different classes of lever, then we can see that in class 1 lever we can have the mechanical advantage and velocity ratio either greater than 1, equals to 1, or less than 1. This is because the fulcrum which is present between the load and effort. If we move the fulcrum closer towards the load, then we will have effort arm greater than to the load arm. Hence, the calculation which we are going to get for this is greater than 1. And we know this thing. If the mechanical advantage is greater than 1, this denotes that it is a force multiplier. Whereas, if we take the fulcrum towards the effort, then our effort arm will become less than to the load arm, due to which our calculation will show that the mechanical advantage is less than 1, which we know as a speed multiplier. And if we keep the fulcrum exactly at the middle of effort and load, then we will observe that the simple machine or the lever which we are using, it is just to use to change the direction of the force applied. But in the case of class 2 lever, we observe that the mechanical advantage and velocity ratio used to be always greater than 1. It means that it is always a force multiplier because the load arm is always less than to the effort arm. In the case 3, when we come for the third class of lever, in that one, we used to observe that the mechanical advantage and velocity ratio always remains less than 1. This is because the effort arm used to be always less than to the load arm, which shows that this kind of lever is a speed multiplier or speed gainer. Now, let us understand about another simple machine, that is a pulley. A pulley is a wheel that carries a flexible rope, cord, cable, chain or belt on its rim. Pulleys are used either in a single form or in a combination to transmit the energy and motion. The original or primary use for a pulley was to make the work easier by lifting heavy items. The main benefit of a pulley or a pulley system is that it can actually reduce the amount of force necessary to lift heavy objects and redistribute the direction of the force necessary to lift heavy objects from one place to another. You can see pulleys in many places, such as in an elevator and in a crane. Pulleys can be classified into many groups as a fixed pulley, a movable pulley, a compound pulley, a complex pulley, a block and tackle system, and a cone system. Out of all these, we will study about a single fixed pulley, a single movable pulley. In a compound pulley, we will try to understand the set of a single movable pulley with a single fixed pulley, or a single fixed pulley with fewer movable pulleys. And then we will also go through the block and tackle system. So let's understand. A single fixed pulley. A single fixed pulley is a kind of pulley where the pulley itself is hanged or placed on a rigid surface. Thus, the pulley itself doesn't change its position. It just goes around its axis. In a single fixed pulley, we have the mechanical advantage and the velocity ratio equals to 1. Here, for an ideal condition, we take the mass of the string and the friction 0. In a single fixed pulley, we used to observe that we use that kind of pulley just to change the direction of the force applied. You can calculate the mechanical advantage and velocity ratio with this simple formula. Here you can see a single fixed pulley is placed on a rigid surface. The load is placed to one of its string and the effort when applied to the other end of the string. The load gets balanced with the tension force applied by the string in the upward direction, whereas the effort been balanced or encountered by the tension force applied by the string from the other side. Hence, the load becomes equals to the tension applied by the string. Similarly, the effort also gets equal to the tension applied by the string from the other end. When you go for the calculation of this mechanical advantage with this value, you will come to know that the mechanical advantage is equals to 1. And as we had discussed earlier, if the mechanical advantage is equals to 1, then that kind of simple machine is used to change the direction only. Let's understand how to calculate the velocity ratio of a single fixed pulley. In a single fixed pulley, if we need to calculate the velocity ratio, then we have to identify the displacement of effort with displacement of load. In a single fixed pulley, the effort been moved as much the load moves. Means if you will take the effort moved by 1 meter, then the load will also move by 1 meter in its opposite direction. Hence, you will get the value of displacement of effort equals to the displacement of load, which will result to the velocity ratio as 1. When the mechanical advantage and velocity ratio is 1, then the efficiency of the machine is taken as 100%. But students, remember this, that this condition can be only observed for the ideal situation. Let's understand about single movable pulley. A single movable pulley is little different than to the single fixed pulley. In a single movable pulley, we used to observe that the pulley itself moves with the load, what we haven't seen in the previous one. Here, one of the string gets connected with the rigid surface and it goes around the pulley to the other end, and the load used to hang with the pulley. So when the force been applied over here, then we used to observe that the pulley gets moved with the load. Hence, when we go for the calculation, we find the mechanical advantage and velocity ratio of a single movable pulley used to be 2. Let's understand how this happens. This is because of the arrangement of pulley along the strings. Here, the pulley gets balanced through both the ends of the string. One of the side of the string is placed with the rigid surface and another side of the string is free to apply the effort. When you move the effort over there, then you find that the load moves with the pulley because the load and the pulley both are getting balanced with the same string. So you can say the load gets distributed, or the amount of load gets distributed for both the ends of the string, which balances it out. Here you can see a simple calculation of the load. So the load whatever been applied over here, it gets balanced by two sides of tension force. The sum of that will be 2T. Whereas the effort been applied to only one end of the string, thus it is equals to one tension force applied by the string. When we put all this information in the calculated value of mechanical advantage, we get it as 2T by T, and thus the answer comes to 2. In the same way, when we go for the displacement of effort with regarding to displacement of load, then also it is little different than what we had seen in the single fixed pulley. In this case, when the effort been moved up, say as by 1 meter, then the load gets only moved by half a meter. Why it is so? It is because when the effort end been taken or shortened by 1 meter, then from both the ends of the string, half a meter and half a meter gets reduced down, which results to the decrease in the height of the load by only half a meter. So you can say that the displacement of effort is double of the displacement of load. And when you put this quantity in the calculation, you find that the velocity ratio is also 2. With this calculation, when we come to know that the mechanical advantage and velocity ratio both are greater than 1, then it means that it is a force multiplier. Because if the mechanical advantage and velocity ratio gets greater than 1, then we had already understood that it says to be a force multiplier machine. So this kind of machine is a force multiplier. But students, here is one problem. When we observe for a single movable pulley, then the applicable force is not according to our choice, or the direction of the force which we are applying, that is not in a very appropriate manner. So we need to change the direction of the force applied in this kind of machine so that we can take more from this. Here, a combination of a pulley. You can see a single fixed pulley been connected with a single movable pulley to make it more efficient. We had already understood that a single fixed pulley used to have a condition where it has a mechanical advantage equals to 1, which denotes that it is mainly used to change the direction of the force. On the other hand, when we had seen a single movable pulley, we found that its mechanical advantage is greater than 1. It means that it is a force multiplier. But the direction of the force applied in a single movable pulley is not in a very convenient manner. So what we used to do, we add this single movable pulley with a single fixed pulley. And when we do so, then we can change the direction of the force applied, which will help us to do the work in a good and an efficient way. You can increase the number of single movable pulley with one single fixed pulley to get more efficiency, or you can say the amount of force can be enhanced by increasing the number of movable pulleys along a single fixed pulley. Here is one calculation by which you can see that the efficiency of a combined pulley or a composite pulley gets equals to the power of the number of pulleys what we are putting over here. Here I will request that pause the video and go through this simple derivation of the equation, which will help you to understand the condition. Now let us understand about one more kind of a combination pulley as a block and tackle system. A block and tackle or only tackle is a system of two or more pulleys with a rope or cable threaded between them, usually used to lift heavy loads. The pulleys are assembled to form blocks, and then blocks are paired so that one is fixed and one moves with the load. Here, the number of pulleys in the whole system gives the mechanical advantage and velocity ratio of that system. Here, the efficiency of the machine is considered to be as 100% in an ideal condition. A block and tackle system used to consist of an upper and lower block. The number of pulleys in these blocks can be different. It can be in a set of 1 plus 1 or 2 plus 1 or 3 plus 2 or 4 plus 3 sets, where the upper block used to have more number of pulleys than compared to the lower block. When we go for the calculation, then we find that the total number of pulleys whichever is present in the system is equals to the number of strings or the threads present in the system, and that will give us the total amount of mechanical advantage and velocity ratio.